Each year, the sea level rises,
setting off irreversible chain reactions beyond human control.
10 hottest years ever measured.
Climate change is our single greatest security threat.
You are failing us.
Governments know it. Even the United States military knows it. None of this is rhetoric, and none of it is hysteria. It is fact.
House on fire.
Welcome to the House on Fire podcast, powered by the Clio Institute. I'm your host, Dania Toledo, coming to you from ground zero of the climate crisis, Miami, Florida. We are here at the Cooperative Institute for Marine and Atmospheric Studies on historic Virginia Key. Just rolls off the tongue. And today I'm going to be talking to a world-renowned climate expert from the University of Miami's Rosenstiel School. Welcome to House on Fire, just to make this a little more formal. Could you please introduce yourself and give us your job title?
Okay, my name's Ben Kirtman. I'm a professor of atmospheric sciences here at the Rosenstiel School. I'm also the director of the Cooperative Institute for Marine and Atmospheric Studies, and I am the deputy director for the Institute for Data Science and Computing. And the university always likes me to mention that I am the William Middleton Endowed Chair in Earth Sciences.
So overqualified for everybody's
Lots of
vision.
titles. That's what academics do. We collect titles.
Amazing. And could you tell us a bit more about what your job entails on a day-to-day basis?
Well, I spend the bulk of my time researching how the climate system works. I'm a climate modeler, so I use computer climate models, which are imperfect, far from perfect, to try to glean some understanding of how the climate system works, how it responds to changes in greenhouse gases, methane, and other things, but also just its internal variability, El Nino, things you've heard of before.
Of course. So let's talk about this historic marine heat wave of 2023.
Yeah, crazy.
In July, the water temperature of South Florida's Manatee Bay measured the world record of 101.1 degrees Fahrenheit. Can you give us a sense of the magnitude and the historical ramifications of this measurement?
Yeah, so it is what we've been seeing in the world's oceans, not just off the coast of Florida, but in the world's oceans is out of bounds. It's warming levels we saw this summer throughout the world's oceans. The difference from average is the biggest change we've seen in the historical record in any 1 year. The biggest change we've seen in the historical record, just by far, not even close. Mm-hmm. Locally, we saw a marine heat wave here. In terms of historical context, order 10, 12, maybe 15 degrees Fahrenheit above normal, what one would expect. Those temperatures, a few more degrees, it's unsafe for humans to go in the water.
Yeah, absolutely. And to that point, to add some context, the U.S. Consumer Product Safety Commission states that sitting in a hot tub at above 104 degrees is bad for your health, like you were just saying.
Yeah.
So if that's true, what is the impact to marine life when this ocean temperature is at 101 degrees Fahrenheit?
So there's been a fair amount of media coverage of some of the impacts, in particular coral reef bleaching. Those temperatures are really difficult for the corals to survive, and that you can sort of it's in the middle of the food chain, but it's a really important component to the food chain of the ocean. And so if your coral reefs die, the whole ecosystem could collapse. And so there were major efforts to try to rescue those coral reefs, bring them back into the lab, keep them alive, and then replant them later on. Things have cooled down, so there are efforts, some of the restoration efforts, and some have been successful and some haven't.
Of course. And are these water temperatures localized to South Florida, or are they suggestive of a trend across, say, the Atlantic Ocean, for instance?
Yeah, the world's oceans, if you look at summertime temperatures this year in the world's oceans, it lit up red everywhere, almost everywhere. There were very few places where temperatures were below normal. So it's just been, I don't know how to, I just don't have words for it, how crazy, bonkers this summer was in terms of the world's ocean temperatures.
Yeah, no, that's it. And it tracks with, say, our temperatures just regularly on land even. So you had said in an interview that we haven't seen this type of change in the Atlantic Ocean water temperatures in, say, 125,000 years. Can you explain that a little further?
Yeah, so if you go, we have proxy records. We can guess. They're educated guesses,
Yeah.
but they're still educated. We have records of what the ocean temperatures might look like on an area average sense from coral reef measurements, coral drilling, going back, many years. And so we can reconstruct what the temperatures look like. And the decade to decade changes in temperatures were relatively small compared to what happened this summer. It's just genuinely out of bounds. And certainly part of it is this perfect storm, if you will, or confluence of events. We have an ongoing El Nino, which significantly warms the climate system. Climate change is running at pace and has been for some time, so we're seeing the warming. So these things are all coming together, but
And
amplifying each other. But even then, we haven't seen. That's happened in the past. Even then, we haven't seen temperatures like this, temperature changes like this. So it's alarming. It's on the very edge of what we would consider some element of natural variability, El Nino plus the climate change signal. So climate change, we smooth things so it looks like a smooth curve, but the climate system doesn't really respond that way. It goes in fits and starts. And so we might have just seen a dramatic change in the climate system. It might have had a big start, and this might be the beginning of the new normal.
That's so much to digest in one go. And so with these ocean temperatures changing drastically, how much of it can you say would be attributed to climate change or greenhouse gas emissions?
So I think that's an open question still. People are going to dig into that.
They're still in the process of researching.
Analyzing the data. We call these attribution studies or fingerprinting or whatever you want to call it. But there's going to be an effort to pull out the part of the warming that was due to El Nino, and then the part that was due to climate change, and the part that's unexplained. Could be related to reductions in aerosols, so more solar radiation is getting through, warming. Lots of other possible explanations. So there's going to be a lot of research to try to decompose what happened this past summer. My sense is a big signal is going to remain the climate change signal, the greenhouse gas forced response.
So the temperatures in the North Atlantic have been steadily rising for years. But in 2023, like you've mentioned multiple times already, there's been a huge spike. Have we reached what some may say, or some may call, a tipping point?
My knee-jerk reaction is this isn't a tipping point. This is I think we're going to see this more and more, ratcheting, these fits and starts of climate change, ratcheting up. It's going to be thump. We're going to have a big year, maybe another 5 years from now. Thump, we'll have another big year. So there's this ratcheting up. I don't believe we've hit a tipping point, in the sense that the climate, the way I think of a tipping point is the climate system has gone into a new regime where we're stuck. It would be very hard to knock it out of this new regime. We've gone into, in the geological record, we've had ice ages, right? So have we gone into a totally new climate regime? I don't think that's the case. I think that if we finally, had the collective will to seriously reduce greenhouse gases, that in 30 or 40 years, we could see the climate system start to return to something that might be more consistent with the 1950s or 1960s.
That's so awesome to hear. Also,
yeah. So I always tell people, don't despair. It was a bad year, and it should be a call to action.
Absolutely.
We should take it very seriously. But I don't think we should despair. I don't think we've crossed the tipping point. I don't think we're at a point where we cannot recover a more livable climate.
That's amazing. And with the recorded temperature with the temperature of 101 degrees being recorded in Manatee Bay, what is the significance of Manatee Bay? Why are measurements taken there in particular rather than other places in South Florida?
I don't know if I have a good answer for that other than the historical. That's, I'm sure it's important for the local ecosystem, the local economy. It's an easy place to monitor. So I think that's, measurements are taken there. And we don't want to move where we measure things.
You want something consistent.
Right.
All right, that makes sense. So some experts would say high temperatures are changing ocean currents, which would affect our weather patterns. Can you explain how that might function?
So the classic example is the Gulf Stream, right? So the Gulf Stream is this ribbon of relatively fast current, relatively warm water. It's bringing warm waters along the Atlantic coast all the way over to Europe. It's bringing subtropical and tropical waters poleward, and often used for an explanation why Europe is warmer than it could be. Okay, so one argument is, and there's some evidence for this, that the Gulf Stream is weakening, and that has a profound effect in how much heat is transported from the tropics to the extratropics. That's an important mechanism. But also, when the Gulf Stream weakens, that has a very profound local effect, particularly along the coast of Florida and the north and the mid-Atlantic. When the Gulf Stream weakens, that can contribute to sea level rise. And so you have this, nice warm pool, weaker current. So it's really warm. That can amplify storms as they come over those warm waters. That can increase the storm surge, onshore wind, which could increase the flooding just from the meteorological conditions. But the weakening of the ocean current also tends to leave sea level higher than it normally would be. When the current's really strong, it's sort of sweeping away water. Sea level gets suppressed, and when the current is weaker, sea level rises. So it's sort of this, coming together of so many factors. So you can have, rising seas due to the weakening of the current, rising seas due to the thermal expansion, rising seas because that current is getting warmer and warmer, and then
stronger.
And then you can have more storms. Those storms are more vigorous. So it's sort of like the perfect storm of perfect storms, right? Everything coming together, giving you not just the sea level rise signal, but the compound flooding, the water that's coming from the ocean, the water that's coming from the air at the same time. All of these things coming together. So we are quite concerned about a weakening current.
And sticking to that Gulf Stream, is it true that it could possibly collapse soon? And if so, what would be the effects of that?
Yeah, I understand your question. There was a recent paper that came out. I think it came out in either Science or Nature, one of the popular science journals, making the argument, primarily a statistical argument, that it could collapse in some window. I think there's some issues with that study.
Okay.
I think a lot of scientists have issues with that study. I think the evidence that a collapse is imminent is not there. But a continued, yes, we should be
Thank
grateful
goodness.
that that's the case. But a continued weakening of that current, we are seeing that, and that is a problem. So just because the Gulf Stream hasn't collapsed, that the meridional overturning circulation hasn't collapsed, doesn't mean that we can relax and not try to deal with the mitigation problem that we have.
Of course. And then you've mentioned a few times already El Nino.
Yes.
And we hear about El Nino a lot, but I don't think that many people truly understand what it is. So could you explain El Nino for the regular person listening to this podcast who may not know?
Okay. I'm glad you asked. I'm actually teaching a class right now, just before you guys
so
came.
Awesome.
I would call the class Everything You Wanted to Know About El Nino, but you were afraid to ask. It's that kind
nice.
of class, right? So the simplest explanation for El Nino is the tropical Pacific during an El Nino, in the deep tropical Pacific, so really near the equator, gets warmer than normal. Okay, and then the opposite phase, which is often referred to as La Nina, it's colder than normal, and the system kind of oscillates between those two states irregularly, so somewhere between 2 and 7 years is sort of the periodicity. So it's really quite broad. And what happens when the tropical Pacific really warms up, it shifts where it rains in the tropics. Okay, so the rain tends to follow where the warmest water is. So if you warm up things in the eastern tropical Pacific, the rainfall shifts from the west towards the east. And that shift in rainfall completely disrupts weather patterns around the world. It shifts weather patterns over North America, over Australia, everywhere. It's so disruptive. It's really quite remarkable.
And it's so interesting that that's over such a specific area. Yeah, the Pacific, and it impacts the whole globe.
It impacts the whole globe. So
interesting.
That's how I started my career, is studying El Nino. So it's a fascinating phenomenon, and it has these global impacts and affects. It warms the whole globe. It shifts weather patterns. So this coming winter, we're in the midst of an El Nino. This coming winter here, southeast U.S., there's a very, very high probability that we're going to have a wet winter. And that's because of the way the storm tracks have been shifted by this warm water in the eastern tropical Pacific.
Interesting. So when it comes to this summer's rising ocean temperatures, can you separate the effects of El Nino and climate change?
You can. It's a statistical calculation, so there's error bars associated with it. But you can, based on how El Nino has affected things in the past. We can go back to some of the modeling tools that I use and do experiments where we have no climate change in the model and we only have El Nino. And so we can say, well, this is the range of possible outcomes due to El Nino without climate change. Then you can go back and do it again with climate change
and not El Nino.
Yeah.
Okay.
So you can do those kinds of experiments. And those are really areas where we're writing proposals and trying to get research funding to do those calculations so we can quantify those things. So yes, we think we can answer those questions. But it's research. It has error bars. It has uncertainty, and it depends on the fidelity of your modeling tools. And our models are imperfect. In fact, if they were perfect, what would you need me for?
That's so true. That's why we have people like you back there.
Yes.
Making sure that you're able to digest the information.
That's right. So what climate scientists do, or modelers like myself, is we take these imperfect tools and we try to use our understanding of how things work, the modeling tools, to try to say something about how the climate system works. And that's hard because our tools are imperfect and our understanding is imperfect.
Absolutely. And so much of this discussion has been warming waters cause stronger effects, whether it be just higher sea levels, stronger storms, etc. And we're just now finishing up South Florida's hurricane season.
Yes.
Considering the high ocean temperatures we've been seeing and the effect of El Nino, why do you think we've experienced a relatively mild, knocking on wood, hurricane season?
So it's a fantastic question, and it has all kinds of interesting avenues and subtleties. So historically, when you have an El Nino, that typically increases the wind shear in the Atlantic. El Nino has these global effects. So one of the things it increases is the shear in the Atlantic. And if you think about hurricanes, they're very upright, right? Very tall and upright. And if you have wind shear, you're sort of shearing off the storms, making them tilt, and they don't form as well. So El Nino tends to actually reduce the total number of storms. And so if you look at the El Nino forecast, the hurricane forecast that was issued this spring, this previous spring, they were saying, well, there's an El Nino effect, so we think it's going to be, but the Atlantic is really warm, which tends to enhance hurricanes, and so they kind of hedged and said near normal hurricane season, or maybe a little bit weaker.
Okay.
Because El Nino would normally weaken it. As the season evolved and they updated the forecast at the beginning of the summer, I think they updated in August, they updated it with a more active year. They updated it with a more active year because the Atlantic has gotten so warm. Now, the subtlety here is when you actually look at the total storm energy, the total storm count, it was actually above normal.
And we've had really wild rainstorms, lots of flooding.
Lots of hurricanes.
Yeah.
But a lot of them have been recurving and staying out at sea, and so we haven't had so many impacts.
So they've just been kind of like circulating in the ocean.
Right.
Okay.
And that's an El Nino effect.
Interesting.
Actually, so there's this feature. You might have heard it called the Bermuda High. but we call it the North Atlantic Subtropical High. And that partially steers the storms. And so when it pushes further southwest, it'll steer storms more towards landfalling storms. When it retreats, then the storms recurve and stay out at sea. And an El Nino effect is to make that subtropical high retreat to the northeast. So it retreated this year. So we saw a lot of storms.
It never hit land.
That's right. They were recurving storms.
Oh, that's so good to know, and such an important way to keep in mind how El Nino affects so many things.
It does.
What are your personal feelings about the future of our planet, given this unprecedented marine heat wave? And would you say that these changes are still reversible? And I feel like that you've sort of answered this question earlier, but I want to get a more in-depth.
Sure. So the way I think about climate change is that there's two fronts that we have to, and they're clearly related to each other, but there are two fronts that we have to push on really hard. The first front is what you might hear about a lot in the news, and that's the mitigation problem. How are we going to reduce CO2 emissions, scrub the atmosphere of CO2 in order to reverse the long-term trend of warming? And I don't think we've crossed any tipping points. I do believe, however, that that less than 2 degree threshold, or trying to keep the warming down to 1.5 degrees, we are going to hit that. And so given that that's going to happen, at the same time, we need to really think very, very carefully about adaptation. How are we going to live with a warmer world, a wetter world? How are we going to do those things? That's a generational problem. If people need to, relocate from the coast, live more inland or in higher ground, we need to think about our transportation systems. We need to think about everything. And that's a generational problem.
And even considering people living in islands just surrounded by water, that's truly.
And the Caribbean, the warming that we're going to see is going to be a big threat to the Caribbean island states, and we're going to have to, as a world, we're going to have to come together and figure out how to help them adapt. And at the same time, we have a long way to go in terms of reducing greenhouse gas emissions. Even even in this country, the transportation sector is the largest source of CO2 in this country. And we're still struggling to adapt electric vehicles. We're still struggling to get everybody at a minimum in a hybrid. But we really need to work on our collective will there.
And also our public transit system. So much of the issue with transportation vehicles would be greatly diminished if the country as a whole could establish a really good public transit system.
That's right. So public transportation is a great solution to the problem. And locally, there was a great promise with the Miami Metro. It hasn't lived up to that promise yet, but it could. And I think a generational solution would be in the next 15, 20, 25 years, we really ramp up our public transportation so that you don't need a car. That would be fantastic.
Amazing, honestly. Yes. And then before we go, could you tell us about some interesting studies or papers that you've been working on in recent years that you would like to share?
There's so many. One of the, it's hard to call. I feel guilty about calling any one study. I do so many papers collaboratively, and so calling any one of them out, my collaborators, my students that are working on these papers.
Well, if you would love to give the,
but I wouldn't be able to call out the others. I think the stuff the research that we're most excited about at the moment is to try to think about providing climate information across timescales. So what's going to happen in the next few weeks, what's going to happen in the next few months, what's going to happen in the next few years, what's going to happen in the next few decades, to provide that kind of all across those timescales information that is actionable for the individual, for local governments, for someone that's got to think about resource allocations. So really making sure that the science we're doing is driven by the decision support need. What decision needs to be made? because that affects how we do our science. It may be that I think something is important, but South Florida Water Management is worried about, no, we're worried about 3 days in a row where the rainfall is intense. We don't care, how many times it happens one day. We need to know when it happens day after day. If it's 3 days in a row, then it challenges our water management systems beyond what we can do. So it's and that would affect how I look at the models and how I put things together. And so it's that kind of interaction with the people that are actually making the decisions that's affecting how we're going to do our science. That's what we're most excited about.
That research sounds super exciting, and honestly would be so helpful to many of, like you said, the decision makers in the years to come as you start working on that. And I kind of want to, before we start wrapping things up, ask you about your feelings about climate change. And more specifically, how do you think we can remain optimistic considering all of the things that we've seen over the summer with the warming temperatures in the ocean, on land, etc.?
Great question. My wife always teases me I'm no fun at parties because everyone asks me all these climate change questions, and all the news feels bad. But I try to urge people not to despair for a couple of reasons. One, I think despair leads to inaction. So
I highly agree.
So all the things that we're seeing, I think, are calls to action. And as I've said before, I don't think we've crossed any tipping points. I think we are dangerously close to some profoundly difficult situations. But I also believe if we start today, we start right now dealing with the generational problem of adaptation, and we start right now building that collective will to seriously reduce CO2, 50, 60 years from now, we'll breathe with a sigh of relief. We're in for a rocky road for the next 30 years or so. It's going to be challenging because we've made a commitment to another 30 years of warming. If we zeroed out the greenhouse gases today, we're going to have 30 more years of warming. We've made a commitment to that. And so that adaptation problem, how are we going to do that? How are we going to ensure that everybody has equal access to resources and that it's done in an equitable way? That's hard stuff. We have to start doing that right now. But I honestly believe we can do it. We can do the big things. We've done big things in the past. And it's just, gathering that collective will to say, okay, that's it. We're going to start dealing with it. And, there are some things that are happening right now. For example, the federal government has decided that we have a National Weather Service that issues, serious weather warnings all the time. That's to save property and life. They're starting to build a National Climate Service. You're going to start hearing more and more about it.
Oh, that's so awesome.
And the National Climate Service, that's going to be a big ingredient of how do we, make a better world for everybody. And so I think things are happening. There's still so much more that has to be done, and we have to really double down. We have to take a very holistic view of things, and we have to be very, very careful that everybody has equal access to that critical information, infrastructure, resources for the adaptation problem, and we really need to bite off the mitigation problem. But I'm optimistic we can do it.
We can still manage to deal with whatever comes our way. We just have to really kind of like nudge at the people in power to make those changes.
That's right. I mean, your generation, when I talk to people of your generation, they're, you ask them what they're worried about, and often the biggest issue is climate change.
I know it's one of mine.
Yeah, and I think they're going to start demanding. I think that generation is going to say, come of age, is going to start demanding that we start doing something.
Go us. Well, with that in mind, is there anything else you'd like to share with our listeners before we finish up today?
Oh, no. I whenever I'm interviewed, I think of that critical thing that I didn't mention, but it always comes about 2 to 3 hours after the interview. So at the moment, I really don't have anything, but give me a call in 2 or 3 hours, and I might have something for you.
Sounds good. Well, if you think of it, let us know. We'll
I sure
definitely
will.
make sure to slide that in there. But thank you so much for your time today.
Thank you. Appreciate it.
And that's it for today's episode of House on Fire. I'm so glad we can end on a somewhat positive note about the future of our climate. House on Fire is powered by the Clio Institute and could not exist without the support of the Lynn and Lewis Wolfson II Family Foundation. Today's episode is hosted by me, Dania Toledo, and produced by Michael Landsberg and Ryan Ners of Unicorn Fire Studio. The intro music is composed by the Microscopic Orchestra. If you like what we do here at House on Fire, don't forget to leave us a 5-star review on whatever podcast platform you're using. It really helps us out a lot. And if you're watching on YouTube, don't forget to leave us a like, subscribe, and hit that notification bell so that you stay in the know of when we drop a new episode. Until next time, see you soon.